Let's explore one of the most important groups in the periodic table, Group 7, the halogens. The halogens are non-metal elements found in a vertical column on the right-hand side of the periodic table. They exist as simple molecules, meaning each one is made up of two atoms joined together by a single covalent bond. For example, chlorine exists as Cl2. Now, the halogens show clear trends in both their physical and chemical properties. Let's start with the physical properties. If we look at chlorine, bromine and iodine at room temperature, we notice something interesting. Chlorine is a gas, bromine is a liquid, iodine is a solid. So as we go down the group, the state changes from gas to liquid to solid. This tells us that the melting and boiling points increase down the group. But why does this happen? There are three key reasons. The molecules become larger, the intermolecular forces between them become stronger, and more energy is needed to overcome these forces. Also, like in all groups, the further down you go, the relative molecular mass increases. Now let's move on to the chemical properties. All halogens react in a similar way because they each have 7 electrons in their outer shell. When they react, each atom gains 1 electron to form a negative ion. This gives them a full outer shell, which is a stable arrangement. Here's a key trend you need to remember. Reactivity decreases as you go down group 7. That means chlorine is more reactive than bromine. Bromine is more reactive than iodine. This leads to something called a displacement reaction. A more reactive halogen can displace a less reactive halogen from a solution of its salt. For example, chlorine can displace iodine from potassium iodide solution because chlorine is more reactive. In the next video, we'll look at more examples of displacement reactions and how halogens react with metals and nonmetals. Make sure to subscribe and keep learning. GCSE success starts here.